You know that feeling when you're sure you've answered a question correctly, but the marks you get back don't quite add up? Well, what if you could see the question through the examiner's eyes? That's exactly what we're going to do. We're cracking the code on a real GCSE physics question by using the official mark scheme as our guide so you can see precisely how to lock in every single mark.
Okay, let's jump right in. We're going to tackle question 03 from an AQA higher tier paper. The goal here is to get inside the examiner's head and see what it really takes to get full marks.
So this is our focus. We're up against the multi-part question all about seismic waves. A real classic topic, right? We're going to dissect it piece by piece, just like you would in the real exam. So here's the challenge. This question has a bit of everything. There are calculations, you've got to recall a formula, and then there's one of those longer explanation questions. We're going to break down each part to see precisely where those marks are hiding.
All right, let's get into the calculations and see how to secure those marks. We'll kick things off with a straightforward one marker just to get us warmed up.
First up, question 03.2. We're asked to calculate the frequency of the P wave shown in figure 3. Now the mark scheme tells us this is worth only 1 mark. What does that tell you? It means they're looking for one simple, straight-to-the-point answer, no messing around.
And boom, there's the answer, 0.4 Hertz. The mark scheme is crystal clear. You get 1 mark for just writing 0.4. It's a single, precise value. And just like that, that's 1 mark in the bag.
Okay, now for the main event of this section. Question 03.4 is where the bigger marks are. We need to find the wavelength of a P wave that's traveling at 7,200 meters per second. This one's worth 3 marks, which is a massive clue, right? It means they want to see your method. They want to see how you got to the answer.
So here's how you guarantee all 3 marks. The mark scheme is super specific. Step 1, substitution. You plug the numbers in correctly. 7,200 equals 0.4 times the wavelength. That's your first mark. Step 2, rearrangement. You rework the equation to find the wavelength. So wavelength equals 7,200 divided by 0.4. That's mark number 2. And finally, step 3, you get the final answer, 18,000 meters. Laying it out like this is perfect.
And there it is, 18,000 meters. That is the magic number that secures you that third and final mark.
Now, check this out, because this is where it gets really interesting. This is a direct quote from the official guidance. It says, an answer 18,000 scores 3 marks. That means if you just write down 18,000 with no working at all, you get full marks. It's a risky strategy, for sure, but it shows you just how crucial getting that final number exactly right is.
All right, calculations are done. Let's switch gears and move on to the conceptual side of the question. Here, it's all about what you know, recalling a key formula and then applying your scientific knowledge in an explanation.
This next one is a pure knowledge check. Question 03.3 asks you to simply write down the equation which links frequency, wavelength, and wave speed. It's just a 1-mark question. They just want to see if you know it. No tricks here.
And here's the perfect answer, straight from the mark scheme. Wave speed equals frequency times wavelength. The scheme also says that if you use the symbols, V equals F lambda, that's perfectly acceptable too. Either one gets you the mark.
Okay, here's the final part, the 2-mark explanation. This question wants you to explain why the study of seismic waves provides evidence for the structure of the Earth's core. This is where you need to connect a couple of scientific ideas to build a solid argument.
And the mark scheme is brilliant here. It tells us the 2 crucial points needed for full marks. First, you get 1 mark for stating that S-waves cannot travel through a liquid. Second, you get another mark for stating that because of this, S-waves do not travel through the outer core. You absolutely need both of those points to show the link between the wave's property and the evidence.
So, we've broken down every single part of the question. Now, let's put it all together and see what a perfect set of answers looks like from an examiner's point of view.
Honestly, you can think of this table as your ultimate cheat sheet. It lays out each question right next to its perfect mark scheme approved answer. For 03.2, just 0.4. For 03.3, the equation. For 03.4, the big number, 18,000. And for 03.5, the 2 key facts about S-waves. This is a golden revision tool because it shows you exactly what gets the marks.
So there you have it. Understanding the physics is one half of the battle, for sure. But knowing how to satisfy the mark scheme, well, that's the other half. It's the key to success. And it really makes you wonder, doesn't it? What other exam secrets are hiding in plain sight?